Hello. In this lecture series, we are going to study about the resistive transducer. The main objective of this session is the basic principle of resistive transducer, advantages and disadvantages of transducer, and applications of the transducer. And one example of resistive transducer, that is potentiometer. These are covering in this lecture series. Now, coming to the resistive transducer. The transducer whose resistance varies because of the environmental effect, such type of transducer is known as resistive transducer. The resistive transducer is used for measuring the physical quantities like temperature, displacement, vibrations, etc. And we all know that the resistance is equal to rho L by A. That is, resistance is directly proportional to the length of the conductor, and area also inversely proportional to the area of the conductor, and it also depends on the type of the material, that is rho. This is the basic working principle of resistance transducer, and if we change the transducer resistance can be changed because of the external environmental factors as well as the conductor's physical properties. Now, the advantages of resistive transducer. The following are the advantages of resistive transducer. And both the AC and DC and current or voltage is appropriate for measurement of variable resistance. The resistive transducer gives fast response, and it is available in various sizes and having high range to low range. Now, coming to the applications of resistive transducer. The first one is potentiometer. The resistance of the conductor varies with the variations in length, which is used for measurement of displacement. And second one is resistance thermometer. The resistance of the metal changes because of changes in temperature. This property of the conductor is used for measuring the temperature. And next one is strain gauge. The resistance of the semiconductor material changes with the strain occurs on it. The changes in the shape and size of the conductor is also alter its length and cross-sectional area, which eventually affect its resistance. This property of materials is used for the measurement of the pressure, force, displacement, etc. Now, coming to the thermistor. It works on the principle that temperature coefficient. The temperature coefficient of the material varies with the temperature. The thermistor has a negative temperature coefficient. That is, the negative temperature coefficient means the temperature is inversely proportional to the resistance. That is, if we increase the temperature, the resistance decreases. Now, coming to the first application, potentiometer. Potentiometer is also called electromechanical transducer, which converts the mechanical energy into electrical energy. This mechanical energy is displacement, and this displacement can be either linear displacement or rotational displacement. So, the potentiometer is which converts mechanical energy into electrical energy, and this electrical energy is voltage. So, basically what a potentiometer is doing, it is converting the mechanical energy into electrical energy. The mechanical energy is the form of displacement, and displacement can be either linear or rotational energy. And this electrical energy or output of the potentiometer is always a voltage. So, it is converting a physical quantity into electrical quantities. That is why it is known as electromechanical transducer. And it is dealing with electrical and mechanical signal, and also it is converting the mechanical quantity into electrical quantity. So, it is known as electromechanical transducer. That is, the potentiometer, it is also called the error detecting device. Error detector in control system. It finds the difference between output signal and input signal, and it is inexpensive and easy to apply. Now coming to the types of potentiometer. On the basis of mechanical energy, that is whether the displacement is linear or rotational, the potentiometer, they are divided into mainly two types. First one is translational or linear potentiometer, and second one is rotational potentiometer. The translation potentiometer converts the linear displacement into voltage. And in the case of rotational potentiometer, it converts the rotational displacement into voltage. And these are the examples of rotational and linear potentiometer. In the case of translation potentiometer, when the voltage is applied across the fixed terminal of the potentiometer, the output voltage which is measured across the variable terminal is proportional to the input displacement. That is, coming to the picture, here a potentiometer with a resistance Rp and the total length is Xt, and this is fixed end and this is variable end. Here a wiper is present there, and the wiper is moved from 0 to high range. This displacement is converting into our voltage. So here we are always apply a electrical voltage at the fixed terminal, and this wiper movement is directly converted into output voltage. It is, consider the diagram. Apply input voltage E across the fixed terminal, and if the total resistance of potentiometer is RT and total length of potentiometer is Xt, and we can calculate the resistance per unit length, that is RT divided by total resistance divided by total length, that is RT divided by Xt. And if we move the wiper from 0th position to a middle one, and if the displacement is Xi, then output voltage changes. Output voltage E0 is equal to resistance of output terminal divided by resistance at input terminal into input voltage. Then we can calculate resistance at output terminal, that is resistance per unit length into length of the output terminal, that is R0 is equal to RT by Xt into Xi. And we are applied this equation into our output voltage, that is E0 is equal to RT by Xt into Xt divided by RT into E. Then we can get a value Xi by Xt is equal to E. Here E is a constant voltage and Xt is the length of the potentiometer, that is also constant. Now we can say that E0 is directly proportional to the displacement of wiper moment. Now on concluding, under the ideal condition, the ratio between the output voltage and input voltage is given by E0 by E is equal to Xi by Xt, where Xi is the displacement of the 0th position and Xt is the total length of translation potentiometer. From the equation, we can say that the output voltage is directly proportional to the displacement of wiper. Now coming to the rotational potentiometer. Here, under ideal condition, the ratio between the output voltage and the input voltage is given by E0 by E is equal to theta I by theta t, where theta I is the input angular displacement and theta t is the total length of the wiper, similar to linear potentiometer. Now coming to the resolution of the potentiometer. Resolution of the potentiometer is defined as the ratio of change in output voltage into one step of the supply voltage. The percentage of resolution is equal to delta E by delta ES into 100. That is, delta E is the change in output voltage and delta ES is the one step of the supply voltage. Here, percentage of resolution or rotational equal to 100 divided by number of turns. Now, on conclusion, first we discuss about what is a resistive transducer and the basic working principle of resistive transducer and applications of different resistive transducers and advantages and disadvantages of resistive transducer. And after that, we are coming to the potentiometer, and we defined as the potentiometer, it is a electromechanical device. That is, it is convert the displacement or mechanical energy into a voltage. And after that, we discuss about the types of potentiometer. There are mainly two types of potentiometer. First one is translational or linear potentiometer, and second one is rotational potentiometer. Now, thank you.